Jai Hind everyone. As you are aware that we are discussing different complex type of different subject in this lecture series. In continuation of that, today I am going to discuss the Unit 4 topic, that is error detection and recovery techniques for compiler design. You know that the error detection and recovery technique is work for all the phases from starting to lexical analyzer, then semantic analysis, then syntactic analyzer. After that, it is needed for intermediate code generation, as then code optimization, then machine independent code optimization. After that, machine dependent code optimization, and then code generation. And after that, we will be getting the target code that is basically used with the input for processing the particular input to provide the output. So in this context, today I'm going to discuss this part of error detection and recovery. So if you're seeing this error detection and recovery part, so programmers make mistakes. What type of errors are there? One is compile time error, and then second one is runtime error. So in compiler especially, the compile time error is addressed by this phase. So if you're talking about compile time error, there are three kinds of error. One is lexical phase error, syntactic phase error, and semantic phase error. So whatever error may be generated in any of the phase that is related with these three phases errors, that is lexical, syntactic, and semantic phase error, means everywhere either it is generated in runtime, intermediate code generation phase, or generated in detected in code optimization phase, or detected in code generation phase. Everywhere the kind of errors that may be detected is a kind of three kinds of error, that is lexical phase error, syntactic phase error, and semantic error. So we will discuss how to just find out which kind of error is generated during the particular code execution, and how we will correct those errors. So firstly, we have to detect errors, then we have to correct that error by using some means and ways. So all particular things will be discussed in this topic. Now, what are the sources of errors? So might be there are a lot of particular places where we might be committing mistakes or not check the things properly, then we are getting such kind of error. Like first is algorithmic error. If our algorithm is not correct, definitely we are getting some error. But if you're talking about semantic analysis and we are putting the algorithm of first for finding first of the particular grammar, might be if you are not properly placed that algorithm to finding out the first of any grammar symbol, then it will just produce an algorithmic error. Second thing is coding error. Might be we are typing coding and might be some writing errors are there, some semantic errors are there. Might be we are putting some typecasting problem is there. So second kind of error is coding error. Then a program may exceed a compiler or machine limit. The third kind of error, if you are not putting the proper limitation or proper particular part of ending part or the execution interval, if you are not putting their end part is properly, then definitely the program may exceed or compiler machine limit, means this is kind of infinite error. Then for example, error declaration with too many dimensions to fit into symbol table. So that is a kind of error. Error in the phase of compiler during translating program into object code, might be we are putting such kind of error. The insertion of some transcriptions errors. The second kind of error is transcription error. The insertion of an extra character, deletion of required character, replacement of correct character by an incorrect character. So might be a lot of sources of errors would be predicted during the compilation process. So most important thing is that firstly we have to find out the sources of error, and accordingly we have to generate some remedy to sort out those errors or diagnose those errors and handle those errors, so that our code will be just going in a proper way and we execute the particular compilation process to getting the result. So these are the basic sources of errors. Now the first kind of error is called lexical phase error. Obviously, it will generate the kind of error. It is come into the category of lexical error where we are taking source program as an input and generating tokens in the form of your simple variable expressions and different operator symbols and might be keywords, identifiers. These all are kind of tokens. So might be when you are writing the particular code and you have writing that code such a way where we are not getting the proper token, this may categorize into the error of lexical phase error. So if after some processing lexical analyzer discover that no prefix of remaining input fits to any token class, then invoke error recovery routine. So you are processing some particular statement and you are not getting any token from that statement. Still, you are expecting some of the token from there. So there will be a problem, and that is related with lexical error because you are not getting the token properly. So might be whatever kind of mistakes you have done through which that error may be generated. What is the simplest way to recover it? Skip the erroneous character until left hand side find next token. Alternate whatever expression L dot A means the particular expression part is writing out something, and out of that we are just taking the token, generating the token or discovering the token. So whatever erroneous character, like if you are writing F, A equals to 0. Suppose that is a kind of writing a code. So what is that? Because you are misplaced or you are mistakenly not putting the space in between if and A, because if is a keyword and a small a is an identifier. So this is a kind of error. So what you have to do, whatever mistake you have done, you have to improve that and you have to write in this form. So that is basically called the recovery from lexical error. What is the disadvantage of this? Set the problems for next phase of compiler. If you are recovering in a partial way, might be some of the problem maybe go into the next phase when you are getting the execution of your semantic analysis or syntax analysis. So there should be some problem maybe arise if you are not handling the errors in previous phase. For example, comments, number string, etc. So there is a program 3.14 that is CSC department. What is the problem with that? Because you are not completing this particular part with this code. So that code is missing. So if that double comma is missing, definitely it will not execute it properly. So that is a kind of error which is just done in lexical phase. How we can recover this? So the parser discovers an error. What are error recovery? The parser discovers an error. If some of the particular part will be getting into the next phase and the parser discovers an error at that moment, if any unwanted character occurs, then delete that character to recover error. So if you are finding that some of the particular portion is written in the form of where some particular unwanted character that is not needed on that place, that may be put up in that place. So what we will do, we have to just remove that character and correct that statement. After that it will be taken by parser, because whatever output you are producing in lexical analysis, that will require for parser, means syntax analysis. Why? Every time parser demands the token, and at that time the lexical analyzer will generate the token. Third, rejects input symbol until a synchronizing token, usually a statement delimiter has, like semicolon, end is encountered. So what important thing, if you are getting such kind of thing, means that is the basically ending of a particular token. So like if I am writing if a equals to 0, very simple example. So I am just reading that. I and F. What we are getting here? Here we are getting some blank space. So what it means? Whatever we have just read out from I to F or before this blank space, that is basically a kind of token, because blank space is an indication that some of the token is already extracted till that, and after that new token will be started. But if you are missing that misplay, that particular blank space, definitely we are getting confused and we are just taking that if A as variable. So that might be possible for mistake. But when we are just checking that that particular part is just representing some of the code, at that moment we will find that this part is written in this form, and then only we have to just place this blank space to generate this variable. Now parser detects stack entry until finds an entry with which it can continue parsing. So whatever input you have taken from syntax lexical analysis, that must be used by syntax analysis. So at the time of syntax analysis execution, if some of the problem arises during the whole process, and most probably it would arise during stack implementation, so the parser will check the problem for that. Either it is a part of syntax analysis or lexical analysis, and if it is lexical analysis error, and it will get that, so immediately the error recovery routine will be called and the particular error will be resolved, and then after it this process will be started. So that is error recovery for lexical analysis. Now we are talking about syntactic error. So basically lexical errors are very simple kind of errors, and it will just removed by very simplest processes. We can check the particular code, we can read out the code properly, we are getting some particular misplacement, so we can check that might be we are misspelled keyword, or we are just writing some code where the particular alphabet or sentence were not correct, words are not correct, keyword is writing down in some different manner, we are not using properly variables, some symbols are unwantedly used. So such kind of errors will be just in category of this lexical analysis. The most important error is a syntactic error, and it is very important error because a particular strong recovery technique will require to remove such kind of error, because this will generate it during the parsing approach. So during parsing approach, if you are getting any error, especially when we are applying some stack implementation and we are getting that table where we are taking the particular inputs to execute the stack implementation and generate the parse tree. So during that process, if some of the problem has been arised, we require some strong error recovery technique for syntactic errors. So what are examples of syntactic error? So like missing right parenthesis. So that missing right parenthesis means it would be a syntactic error, means it is syntax based, because if you are not putting that, this equation is not correctly calculated when you are executing this. So such kind of error, it is deletion error, because you have already deleted this particular part, means whatever is required you have not completed, some of the part is missing, so that is called deletion error. Then extra comma, if you are putting some extra comma like this for statement you are just seeing, that is kind of syntactic error. So you are putting 2 comma, that is semicolon then comma, then it is called insertion error because you have inserted some additional things. It is deletion error because you have just miss out some particular part which is required for this code. Then colon in place of semicolon, that is called replacement error because here we needed the colon, but in hurry when we are typing the particular code, might be we are putting just colon in place of semicolon. So when we are going to execute this code, it will create a problem because that is not matched with the syntactic specification of that particular language. So that is kind of error. Then misspelled keyword, void main. So that is a kind of misspelled keyword. It is called transposition error. So if you are mistakenly write something in incorrect form, like main, the spelling of main is M-A-I-N and you are putting M-I-A-N, and that is only when you are typing in hurry. That is the only problem. So it is called transposition error. extra blank, if you are putting some extra blank, that is also kind of insertion error. So these kind of errors basically called as syntactic error, because your syntax of the program is not correct. That's why it will generate it. When you are compile the program, you will be getting such kind of error easily, because syntactic error will be, because it is related with the syntactic structure of a program, so it will generate it directly, and you will be, the particular place is also identified by the compiler. So you will be getting such kind of error, and these categories of error will be generated in the form of syntactic error. Other difference errors are minimum distance error, correction of syntactic error, theoretical way of defining errors and their location. It is called minimum Hamming distance. So that is a one method we have to correct to let a program P has errors K. Find shortest sequence of error transformations that will map to valid program. For example, if A equals to B, then sum equals to sum plus A, else sum equals to sum minus A. So if you are seeing that if A equals to B, then, so basic problem is that you are seeing that that is basically if and A, there is no difference between if and A. So what is the problem? The minimum Hamming distance equals to 1. Transformation may be the insertion or deletion of a single character. So if you are seeing that we have write if A, you just checked it out. So if A means here one space is required. So it is a kind of basically deletion error, because we need some space over there, but that space is not available over here. So what we will do? We just putting that space. So here that space is given, and if A equals to B, then sum equals to sum plus A, semicolon is placed, else sum equals to sum minus A. So it is corrected. So the minimum Hamming distance equals to 1, because one particular place error is there. Either it is insertion error, deletion error, transposition error, or replacement error, whatever kind of error, but the error prone unit is length of 1. So minimum Hamming distance will be 1, and we have to just putting that space is over here, and we are getting that correct result. How we can recover the syntactic errors? Because when we are putting the value into syntax analysis, it will cause a major problem. So number of approaches are used to resolve such kind of error. One is panic mode recovery. The parser discovers an error. It then discards input symbols till a designated set of synchronizing token is found. So that is basically recovery, panic mode recovery. In panic mode recovery, if during stack implementation, here suppose $AB, here $capital A is there, and here AB dollar is there, and we are not getting capital A to A, any block, any value is there, then what we have to do? If you are getting A and B for any value in table like A and B, here some production is there, but here nothing is there. What we have to do? We have to skip this and synchronize this. Then this particular alphabet is removed from this table. Then we are getting this, and through that we are putting this, and that process is going on. So it is called panic mode recovery. What we have to do? We have to eliminate that particular part which indicated to any error or blank part. So what we are doing? We have to eliminate the particular input from the input alphabet, and again we are finding out some such kind of sequence A produces B, and we are putting that. Through that we are just execute the parsing techniques. But the problem is that synchronizing tokens selected are such that their role in the program is unambiguous. The most important thing, like delimiters, means they will not generate any kind of effective value in that particular code. What is advantage? It is simple and never goes into an infinite loop, because every time you are just removing the particular part, making it convenient for matching with table, and we are using the value of table. So this is never goes into an infinite loop. Like that is example given. E produces T dash, that is a top-down parser. So panic mode recovery, if you are talking about LL1 parsing table for a given grammar, you will see that whatever blank places are there, that is basically error entries. Now we will see. how we can use the algorithm for panic mode recovery. If you are seeing any blank, so I have just talked about that now. $A is given here, A, B, dollar is there. So A and A, we are seeing blank. Here no entry. Then input symbol A is skipped. So what will happen? This particular input symbol is skipped. Else if MA comma A equals to synchronize, otherwise you have to put up this synchronize, then pop off the non-terminal from the top of the stack. So both the process will be used. Might be you will remove this non-terminal from this this particular stack part, or you have removed this input terminal from the input. So both the process will be taken. But if you are skip this small symbol A, then you have to directly skip that. But if you are putting this this particular part, then synchronize is used, and during synchronize this particular non-terminal will be eliminated from that. Else top token is not equals to input symbol, then pop off the token from the stack. Else what is top token? Top token means whatever is stack top is there. If it is not any input symbol, because when we are getting two input symbols, then it is pop off. We have to eliminate the different input symbols from the stack and input alphabet, input set. How? If both are equal, means this input equals to this, then we eliminate both particular part from the input alphabet and stack, and definitely we are getting some result. Through that we can exhaust all the particular input alphabet using this non-terminal, and we are getting the dollar and then last blank entry. So that is the indication of completing this top-down process. So if token is not equals to input symbol, then pop off the token from the stack. If it is not equals to input symbol, again it will a non-terminal. Then what you have to do? You have to just pop off this particular from this stack. Then again whatever previous variable is there, that will take place of that, and top of the stack will change and both the process will be executed. So that is very important. Now this is the processing example. What we are putting, all the particular entry places where the possibility is there, we are getting that on the part of a stack, like T plus is synchronized simply, E right parenthesis is synchronized, E dollar is synchronized. Similarly, T dash no entry, F plus is synchronized, star is synchronized, right parenthesis synchronized, and dollar is synchronized. So where we are putting this synchronized terminal. So if you are seeing follow, so first of follow a particular E, right parenthesis and dollar. So here synchronize is there. Follow of T equals to plus right parenthesis and dollar. So all follow of non-terminal, what we are doing, because whenever why follow is used? Follow is used only when we are having at right hand side some epsilon terminal, means there is no production of that particular terminals related entry will not be found. Then what we have to do? We have to just trigger to the follow. So all follow non-terminal will be putting off this synchronized value. So then perform the operation for the input string star ID star plus ID dollar. If you will see this particular input, that input is not correct for that. So if you are performing this E and star, so there is error. So skip star. Then dollar E, star is skipped, E and ID. ID is in first of E, so it is executed E dash T, F dash DT. Then again we are putting F and plus. So F and plus is error, because F and plus there is no direct. So what we are putting? Synchronize is there. So F is removed. So F has been popped. Again we are putting, and we are getting that completion of this process. Okay. So you will see that if you are getting any terminal symbol into input alphabet, what we have to do? We have to skip or remove from that. If we are getting any particular part, which is basically the part of synchronization, then the non-terminal will be eliminated. So this is very important part, panic mode recovery. The next recovery part we will discuss in next lectures. Thank you very much.